With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is for the reaction A plus B gives C, the following data were obtained. In the first experiment, when initial concentrations of both A and B are 0.1 molar, observed initial rate of formation of C is 1 into 10 raised to power minus 4 mole per liter per minute. In the second experiment, initial concentration of A and B are 0.1 molar and 0.3 molar. The initial rate is 9.0 into 10 raised to power minus 4 mole per liter per minute. In the third experiment, when initial concentrations of both A and B are 0.3 molar, the initial rate is 2.7 into 10 raised to power minus 3 mole per liter per minute. Write rate law for this reaction. Calculate the value of specific rate constant for this reaction. So in the question we are given the reaction which is A plus B gives C. Now for this reaction we have to write the rate law and calculate rate constant. So rate law is basically an expression which gives you relationship between the rate of reaction and the concentration of reactant. So for any reaction, rate law is equal to rate equal to K into, now here reactants are A and B. So concentration of reactant A raised to power M, concentration of reactant B raised to power N. Here K is your rate constant. Now M is order of reaction with respect to A and N is order of reaction with respect to B. Therefore, the total order of reaction is M plus N. Now, three experiments were conducted. For the first experiment, A and B have concentration 0.1 molar, rate is 1 into 10 raised to power minus 4. Therefore, your rate law will become rate is 1 into 10 raised to minus 4 is equal to K into concentration of A is 0.1 raised to M, B is 0.1 raised to N. Consider this as your equation 1. Now, in the second experiment, a rate is 9 into 10 raised to power minus 4 is equal to K into concentration of A is 0.1 raised to M, concentration of B is 0.3 raised to N. This is equation 2. And now in the third experiment, the rate is 2.7 into 10 raised to minus 3 is equal to K into concentration of A and B both are 0.3. Now first we'll have to calculate the values of M and N, then write down the rate law, and then we can calculate the value of K, that is rate constant. So now to calculate the value of N, we'll divide equation 2 by 1. This is equation 2 upon equation 1. Now in this equation, 10 to the power minus 4, 10 to the power minus 4 get cancelled. Therefore 9 is equal to K and K will get cancelled. 0.1 raised to M, 0.1 raised to M get cancelled. So you have 0.3 upon 0.1 raised to power N. Therefore 9 is equal to 3 raised to N. Now 9 can be written as 3 square, which is equal to 3 raised to power N. Therefore N is equal to 2. Now you have N ka value. So to calculate the value of M, divide equation 3 by equation 2. Now in this equation, 2.7 into 10 to the power minus 3 upon 9 into 10 to the power minus 4 is equal to 3. K and K get cancelled. 0.3 raised to n, 0.3 raised to n get cancelled. So you have 0.3 upon 0.1 raised to power m. Therefore 3 is equal to 3m. Here 3 is 3 raised to n. Therefore m is equal to 1. Now you have values of both m and n. Therefore you can calculate the overall order of reaction, which will be 2 plus 1 equal to 3. So the order of reaction is 3. Now we can write the rate law, which will be rate is equal to K into concentration of A raised to power m. So m is equal to 1, and concentration of B raised to power n, where n is equal to 2. So this is your rate law. Now you have to calculate the rate constant. So for this you can consider any one equation and substitute the values of m and n. So we'll consider equation 1. So 1 into 10 to the power minus 4 is equal to K into 0.1 raised to 1, 0.1 raised to 2. Therefore 1 into 10 raised to power minus 4 is equal to K into 0.1 into 0.01. Therefore, K is equal to 1 into 10 raised to power minus 4 upon. Now the value of zero point 0.1 into 0.01 is 1 into 10 to the power minus 3. Therefore, your rate constant K is equal to 0.1. Now, as your order of reaction is 3, and for a third order reaction, the units for K are m raised to power minus 2 minute inverse. Therefore, the unit of rate constant is m raised to power minus 2 per minute. So, this is the value of your specific rate constant. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.